talking with us about the Salmonid Working Group report.
Thank you. Thanks for having me here. I'm one of the co-chairs of the Salmonid Working Group, along with my fellow co-chair Ben Dickinson with Illinois DNR. And much like Jory said, this group is working across multiple jurisdictions with the diverse membership across different agencies and groups. And really the data that I'm presenting here is a culmination of a whole lot of data requests and support from all those agencies that have made this possible. One of the major products that this group produces each year is the predator-prey ratio. This is one of the tools that managers use to sort of understand predator-prey balance in Lake Michigan and adjust stocking rates accordingly. It's shown here in this figure, with the top panel being Chinook salmon biomass. The middle panel is alewife biomass. Those are both derived from statistical catch-at-age models. And then by simply taking the biomass of Chinook salmon and dividing it by the alewife biomass, we produce that predator-prey ratio, which is on the bottom. So that's sort of the relative number of prey to the predators that are present in the lake. That is still in the process of being updated and run with the 2024 data. But we have some other indicators here that I'll talk about that are based on metrics that are taken from fishery-dependent surveys like Creel and the Mass Marking Program, as well as from weir and harbor sampling. So these indicators include the standard weight of a 35-inch Chinook salmon, average weight of age 3 females returning to weirs and harbors, catch rates of Chinook salmon in the charter fishery, and the percent composition of angler harvested salmonines by species. The final two indicators are related to the prey side of that predator-prey balance equation. That's lake-wide biomass of alewives, which is derived from the same catch-at-age model that we use to calculate the predator-prey ratio, and the age structure of the alewife population. So later today we'll hear from USGS folks about the status of the prey fish community in Lake Michigan, so we'll hear a little bit more about that indicator. And obviously I don't have that biomass indicator yet until that model's updated. So we'll focus in on the first 4 indicators today, mostly talking about the predator side of this equation, and then talk a little bit about sort of anticipation for what that predator-prey ratio might end up being once that's actually produced. So our first indicator is the standard weight of a 35-inch Chinook salmon, and these are salmon that are collected in the open waters of Lake Michigan between July 1st and August 15th. Standard weight simply being we fit a length-weight relationship on any given year, and then if you were to estimate the weight of a 35-inch Chinook salmon on any given year from that relationship, that's the standard weight that we're talking about. This year we had a larger amount of data come in than what we've had in the past, thanks to some hard work by folks at Wisconsin DNR to QA/QC and really increase the number of creel samples that we had from that western side of Lake Michigan. So it's really nice to see that, and that sort of allowed us to update this time series with more information from Wisconsin. In general, we see that across the 4 major jurisdictions in Lake Michigan, we see really similar patterns in standard weight through time across each of those locations. That makes a lot of sense. We think that Chinook salmon are relatively well mixed in Lake Michigan at that time of year, so we see similar sizes or similar standard weights across each of those areas. So if I were to take this collectively, we can talk a little bit about some of the patterns. In general, in 2024, we saw a slight increase from 23. And that's likely related to a 23-year class of alewives that might have supported a little bit larger weight at 35 inches. In general, though, this is down from where it had been in the preceding sort of several years, around 2017, 18, 19, that kind of time frame. And that corresponded with relatively low predator-prey ratios, so there were fewer predators out there for the number of prey, so we saw higher standard weights. Other sort of fluctuations that you see in this time series often correspond to things like year classes of alewives. So you see a big peak in 2011 that corresponded to a 2010 year class of alewives, and another peak in 2013 that corresponded to a 2012 year class of alewives. So the dynamics you see here really are nicely related to what we think is going on with the prey fish community. Second indicator is very much in the same sort of vein as that first indicator, and that's the weight of age 3 female Chinook salmon. So these Chinook have spent 4 summers in the lake growing, returning to weirs and harbors where they're collected. These come from a number of different locations around Lake Michigan, so there's several weirs in Wisconsin, including the Besadney anadromous fish facility, Strawberry Creek Weir, and the Root River Weir. In Michigan, we have the Little Manistee River and Medusa Creek, as well as Boardman River Weir. And then in Illinois, there's a number of harbors that are sampled by electrofishing. In general, much like standard weight, we tend to see that similar patterns exist across each of these, although there's a little more variation. And in recent years, we've seen a departure of some of these. So even though trends are often the same, there's as much as a 5 or 6 pound swing between some of these different locations for the size of these age 3 females. I will point out here that we saw one real anomalous value for the Little Manistee River Weir in 2024, but that corresponds to a very low sample size. So the days we were sampling, the run was skewed strongly to males. There were very few females that were present, and the handful of females that we did get were extremely large. So it makes it look like Little Manistee River is much different than what some of these other sites were, but I think it's just driven by that low sample size. Most other locations saw a downward trend. Reducing this down to just a handful of locations, you can see the Strawberry Creek Weir in Wisconsin has been on a downward trajectory over the last 6 years maybe. Medusa Creek in Michigan, we saw a downward trend from 2023, and in harbors in Illinois, we've actually seen an uptick in recent years, so a little different there. Taken as a whole, doing a weighted average of all these different locations, we see that there's been a general downward trend over recent years, corresponding to an increase in the predator-prey ratio and relatively fewer prey available to the number of predators. Third indicator is the catch rate of Chinook salmon in our charter boat fishery. So catch rates tend to be indicative of how many salmon are present, and in 2024 we saw what you're looking at here in the first panel. This is harvest rate or harvest in the charter fishery. The second panel is effort, which has been relatively stable through time relative to harvest, and as a result, harvest rate, which is in the lower panel, has been on an increasing trajectory corresponding to what we see with harvest. So over the last 5 or 6 years, we've seen a pretty sharp increase in harvest rate, which likely reflects higher abundance of Chinook salmon in Lake Michigan. These are some of the highest values that we've seen in the last 12 or so years, and it's been more than a doubling since 2020. Again, that was across jurisdictions, but taken as a whole, we see the same general patterns. So moving back to that previous slide, there was an uptick in Wisconsin, Michigan, and Illinois waters. Indiana has been relatively stable, but taken as a whole on a lake-wide basis, there's been a pretty strong increase in these catch rates. The final indicator that I'm going to talk about here today is the percent composition of angler harvested weight by species. And so while the indicator itself is just the proportion of the sport catch, I'm going to break this down a little bit because I think there's some really interesting patterns that emerge here. So the 5 major salmonids in Lake Michigan are shown in each of the panels. The first panel on the upper left, brown trout, is the smallest portion of the sport harvest that we see. It's been on a declining trajectory. Some of that may be related to just our creel surveys mostly start in April, and so we may miss some of the more important harvest that's happening earlier in the year. In general, always Wisconsin has the highest brown trout harvest relative to the other jurisdictions. Now, compare that to Chinook salmon and note that the scale is an order of magnitude different. Chinook salmon represent the largest portion of harvest every year in Lake Michigan. Much like the previous figure, which was charter catch rates, harvest of Chinook salmon has been on an increasing trajectory, especially in Michigan and Wisconsin waters. Coho salmon, I think, is a really interesting story in 2024. There was a marked increase in catch rates in Michigan, in Illinois, and especially in Wisconsin, where we saw, I'm trying to remember here, I think it was like almost a 50% increase from the previous high value that was in that time series. So just tremendous harvest of coho salmon in 2024 in Wisconsin waters. Also near the highest in the time series for Michigan and Illinois as well. It's noteworthy how high harvest was in Illinois, considering how much less area that jurisdiction occupies than Lake Michigan as a whole. So, pretty impressive catch numbers for coho salmon across jurisdictions. Lake trout, much like Jory described, has been on a declining trajectory, most likely because of catch rates of Chinook salmon and coho salmon. So there's an angler behavior aspect here where a lot of anglers are targeting those silverfish as opposed to lake trout when fishing for those silverfish or better. Steelhead's been relatively more stable through time. It bounces around a little bit, but really the numbers have been more or less constant for the last 20 years, not deviating strongly from that 20-year average. Higher harvest in Wisconsin than what we see in the other jurisdictions. So taking this all as a whole, here again, brown trout is on this downward trend. It represents a very small fraction of harvest in Lake Michigan. Chinook salmon is on that increasing trajectory like we talked about, corresponding to probably higher abundance and relatively good predator-prey conditions leading up to this point. And coho salmon is I think that's really the story here in 2024. It's been extremely interesting. And we see the dynamics of this. So, there's this peak after 2010 that likely corresponds to the 2010 year class of alewives and higher survival and corresponding catch rates in 2011. Same thing in 2013, corresponding to the 2012 year class of alewives. And then in 2015 and 16, we had above average year classes of alewives that correspond to higher catch rates in that time frame for coho. And then again with that 23 year class of alewives, this tremendous increase in harvest of coho salmon. Lake trout, again, this sort of reciprocal pattern with what we're seeing in the Pacific Salmonids. So this downward trajectory. Steelhead, again, bouncing around that sort of 20-year average that we've had. Maybe down a little bit from where it has been, but I think here, with steelhead again, we see some reciprocal pattern with Chinook and coho salmon, where when catch rates for those species are higher, we tend to see a little bit lower harvest of steelhead. Stacking all those lines on top of one another, you can see where total harvest is over time. It looks like we are at the highest value that we've had since about 2012 in terms of overall salmonine harvest, with a large proportion being made up of Chinook and coho. And so that's what this final figure is, and this is what the actual indicator is. So, Chinook salmon's 50% of the harvest. It always makes up most of the harvest. Brown trout really were sort of an insignificant proportion. But here again, the coho salmon thing is really the really interesting piece, where they made up 31% of the harvest, and that absolutely dwarfs the previous high of 23% that was back in 1997. So much higher harvest of those two salmon species, and then correspondingly lake trout harvest made up only 8% in 2024. So those are the indicators I wanted to focus on here. I'm going to spend a few minutes talking about sort of the predator-prey ratio and where I think we're going to be headed here in this coming year, because we actually have the indicators that I've presented on today offer us a pretty good indication of what I think the predator-prey ratio is going to do. So there's a nice negative relationship that you're seeing in the upper left there between the predator-prey ratio in that standard weight of 35-inch Chinook salmon. So as salmon get larger, it's indicative of a lower predator-prey ratio, so more relative, prey for the number of predators that are out there. And that's a pretty decent negative relationship. We see the same thing with the weight of age 3 female Chinook salmon. That's an even stronger relationship. And then we see the opposite pattern with catch rates. So as catch rates increase, that means that there's probably more salmon, and it's likely that there's less prey relative to this number of salmon. So using those sort of relationships, we could reasonably predict where we think the predator-prey ratio is going to be. So that lower panel, the black line is showing the actual modeled predator-prey ratio. Those are our estimates. And then each of those colored lines corresponds to the color of the indicator above, that we're using to then predict what that predator-prey ratio might be. And so we see that the predator-prey ratio has been on an increasing trajectory the last handful of years. Each of these indicators is also showing an increasing trajectory, with the exception of that standard weight, which actually dropped down from 2023. And I think that's driven in large part because of the 2023 year class of alewives in Lake Michigan, which actually resulted in some larger standard weight salmon in 2024. But in general, the pattern has been going up. So relatively fewer prey for the number of predators out there. I would expect that, the predator-prey ratio is going to follow a similar pattern this year of increasing, or, maybe it'll stay in the same ballpark because of that year class of alewives helping us out. So that's where I think, things stand right now with the predator-prey ratio. I'll briefly touch on these last two indicators because I think, we can sort of anticipate a little bit here as well and talk about, their utility for the work that this group is doing. So lake-wide biomass of alewives again comes from our catch-at-age model, which we don't have updated just yet. And the age structure of the alewife population is the other indicator. These things, in my mind, are related by predation mortality. So as predation mortality increases in Lake Michigan, we see biomass going downward. We also see the age structure become truncated to younger individuals because they're simply not living to be, older. So looking at the relationship here, predation mortality now is represented in the top panel, and total biomass is represented in the bottom panel. And I just draw your attention to a couple different time periods. This time period here, in the late 80s and early 90s, is really the only point in this 49-year time series where we see a consistent increase in alewife biomass, which I think is remarkable that over this period of time there's been one very consistent increase in alewife biomass. And that corresponded to a period of predation mortality that was below 0.3. And so that was also a period of time when Chinook salmon were experiencing a bacterial kidney disease outbreak. There was very low survival. And so with lower survival of those salmon, there was lower predation mortality and this marked increase in alewife biomass. Compare that to this period in the mid-2000s, where we saw a continuous decline of alewife biomass over multiple years, and that corresponded to a period of predation mortality that was greater than 0.55. In more recent years, we've seen some highs and lows. So as predation mortality declined, we saw a marked increase in alewife biomass in recent years that was aided by some larger recruitment events. And then in the more recent, 3 or 4 years, we've seen a decline in alewife biomass corresponding to a pretty marked increase in predation mortality. So depending on your management goals, you might be able to adjust alewife biomass by sort of targeting certain mortality rates here, if we think we have that much control of the system. So driving, if we want to increase alewife biomass, we'd really want to reduce that, that predation mortality below 0.3. Stable biomass might be achieved somewhere in that sweet spot between 0.3 and 0.55, and then decreasing alewife biomass would require a predation mortality that's a bit higher based on this sort of retrospective analysis and relatively similar recruitment patterns to what we've been seeing over time. Looking at this all as a whole, here again, this is just a predator-prey ratio from 2023 that'll be updated in coming years. So that top panel is Chinook salmon biomass, middle panel is alewife biomass, which has been declining. The predator-prey ratio is on an increasing trajectory, and then our predation mortality is also on this increasing trajectory. And so that green bar in the lower panel, that shaded area, is sort of that sweet spot where you might expect to have stable alewife biomass. Below that, alewife biomass will be increasing. Above that, and we're likely driving alewife biomass downward. I would expect, given that the indicators that we have this year, and in our results from 2023, that we're going to continue to see alewife biomass decline in 2024. So I think that's where things stand. There's the 2023 report is available on the Fish Commission website if folks want to see it, and we hope to have the 2024 values updated here